Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And in this video today we're going to look at arrays, and we're going to look at an efficient way of swapping values using the CPU. This is basically something that you can't directly do in high-level languages. I don't think you can anyway, and if you can, please comment below and teach me and teach everybody else as well. And so we can kind of make things a little more efficient than we generally can when we're creating general use functions like a swap function or something like that. And that's usually pretty true about assembly language in general. Usually when you're down here at this level at assembly language, you're trying to do something that the compiler either can't or won't do for you, or you kind of know better. In some, most times you really don't, even though you think you do, but sometimes you really do know how to do something more efficient than the compiler can do for you. And that's kind of what this course is about, at least as one of the ways that we go about trying to teach you guys stuff. So here's the problem. I have an array of shorts. I'm going to print them out in a certain order, and then I'm going to swap them around a little bit, and then I'm going to print it out. And in previous assignments, over the years, students generally just print values and try to hard code, and well, that's not if you're not modifying the values of the array, then what are you actually doing? You're just kind of going through all of this just to print out values that don't really matter. You're not really changing the data stored under the hood. You're just giving the facade and the illusion that you are. So if I'm looking at a short array, short A, 4-element array, 1, 2, 3, 4. Short is a 16-bit, so this would be a word, and it will be a signed word. And so I'm going to just call it A, just to keep consistent with what we've got here. And I'm just going to go 1, 2, 3, 4. And I want to make sure this will build. And let's see, ready, and rebuild succeeded. Okay, so that's proper syntax. Excuse me. So that means that A is an array of shorts, of signed shorts. And since it's explicitly described here, but every 2 bytes of storage is where these values are stored. So there's a 1, there's a 2, there's a 3, there's a 4. There's 8 bytes of storage where this guy lives. And that means it's going to be a little more complicated on the assembly language side when it comes to figuring out what memory address to use for these. Not too much more. It's just a simple translation. But you'll see that it's a little more complicated than what you see here. So let's talk about printing these things out. So let's see, I want to move into the EAX register. I want to move A of 0. That's what I like here, A of 0. And then I want to print. Right, int. And you will find, here, let me just add a few more things here, just my boilerplate stuff here. Call wait message, and give it a CRLF. Okay, so you're going to see that this will not compile, or this will not assemble, I guess is the more technical term. Give me a second here, let me pull this error list up. And the reason why, which shows here, the operands must be the same size. EAX is a 32-bit register. A of 0, as of such, when I go to here, is a word, which is this is a double word, this is a word. This does not match up. So for me to be able to copy everything over in a signed manner, I have to make this a signed extension. So now this will work. This will say, go here. I know these guys are stored as words, but why don't you convert them into a double word to move them into the EAX register so I can call out and print the +1. That should go. And there's my +1. All right, cool, fair enough. So now I want to do a space, so I move into the AL register, a space, and then I call write char. And then let me just copy this one more time and say, let's just do things the way I see them on the screen here. And I say, oh, I'll do A1, and I'll do the same thing, print out, whatever. So I should see a 1 and a 2. What do I see? I don't even know what I'll see. Ah, there we go. I see a 512, and you're like, what is going on here? And again, the reason why you see things differently is because when you're dealing in a high-level language, the compiler does work for you. The compiler looks at this A1 and go, oh, you want the first, or I guess technically the second element in this array. I need to move over, and it knows, because it's a short array, it knows to move over 2 bytes for you. You don't know that over here. You're telling the assembler, go over 1 byte. And then do everything you got to do. So you're going to get some weird result because you're using part of this element and part of this element to print something out, and that's not what you want. So you just remember, it's element-based indexing over here in C++ and Java and high-level language land, and it is byte-level addressing at assembly language levels. So if I put a 2 in here, I will now get a 1 and a 2. And there's my 1 and a 2. Okay, so using that understanding, there's a lot of copy-paste here at the moment. You could imagine now if I do a 4 and a 6, now all of this will come together and it should print out 1, 2, 3, 4. Every element in here, there we go, there's my 1, 2, 3, 4. And so every element is represented. So now, if I'm not going to go into functions, and to be honest with you at this point, I'm just making this video just kind of willy-nilly. I don't even remember if that's part of the curriculum at this moment for you guys. And if it is, you could create a function to do this for you, so you don't have to do it over and over and over again yourself, because this is where I go, oh my god, why am I duplicating so much code? Maybe we can do it after we get this thing working. So I'll do CRLF, and I'll do it all again. And so here is where the to-do is going to be, do all the swapping. I'll just put this in here just so I know when I get to it. So print everything out, go to the next line, print everything out again. And so there we go. So now the end goal is to swap everything around so that when I go to print everything else out, it works as I'm expecting it to. And this is should be pretty simple. The only tricky part is remembering exactly what order and how I want to do the things I want to do. Sorry, I got the lawn going outside. Got someone mowing the lawn. It's making some weird noises in here. At least for me, huh? Weird. Okay, so now the one thing you can't do, and it makes total sense when you think about it, is like you can in like C++. If I had a variable x and a variable y, and I just said x equals y, or Python, or you name the language, it just works. But what you don't realize is you can't do this in assembly language, because any line of assembly language code can only access one memory address at a time. Like one memory address per line of assembly code. You can't do this. You have to break this up into 2 lines. And that's because the address bus, all the little wires connecting the CPU and the computer part of the computer to the RAM, like you can only access so many things at one time, and that so many things is 1. So you can always access a register, but you can only access one piece of memory at one time because your hardware, that's like the hardware limitation. And so what we're going to need to do to move some values around and make some exchanges and stuff like that is we're going to need to, excuse me, we're going to need to, I just had a, we're going to need to move something from RAM, from RAM into memory, into our register, and then we can go from there. Sorry, just had a little thing of what's going on here. Okay, so what I mean by that is I want to move into some register, and since we're dealing with shorts, now that everything's kind of printed out in a double word manner, but we can just use words to get our job done, I can move whatever's at A0 into the AX register. And in this case, this will be the 1. Will be a 1, right? So that's what's going on. So then now that I have a 1 stored in the AX register, I can do an exchange operation. It's like there's no reason to write 3 lines of code to do one swap. Excuse me. So that means if I have the 1 and I want to put it, where do I want to put it? I want to put it over here in A3. I can exchange that with A3. I'm sorry, A6, right? See, talked myself into it while I'm trying to do and think and whatever. I want the 3rd element, but I need it in a short manner. I need it 2 bytes per short, so I need it at A6. Okay, and so now inside of here, let's just kind of print out what we got. We're going to have 1, 2, 3, 4. That's what's going on in our array, and the AX register is going to hold the 1. Let's just kind of do it that way. This is the AX register. It's holding the 1, and then this is what we've got here. This is 0, this is 2, this is 4, this is 6. So now what happens here is the 4 is going to be in here. So we're going to have a 1, a 2, a 3, and a 1. And that's because that's what we want here. We want the 1 to be the last element, this element here. And now we have the 4 that we can swap, and we need to swap it over. I don't know why this didn't print out right. I can't stand Blackboard for this. Like, it's all formatted properly on everything that I see. but it will not print everything out on your end properly. I can't change it. I don't know what's going on. So I need this 4 to go into A1, which is actually A2 when it comes to what we want to do. So if I do an exchange with AX and A2, what do I get? What should I get? Or I guess, here, let's just, I think I get print here. Let's just see what we get here. Let's see if we see what we're supposed to see here. And there you go. So with this commented out, you can see that I have 1, 2, 3, 4 to start like I'm supposed to, and now I have 1, 2, 3, 1 like I described. And now with this, what we should end up with here, oops, we should end up with a 1 and a 4 and a 3 and a 1, and the 2 should be in the AX register. So let's print out that and see what we get. And look at that, we've got the 1, 4, 3, 1 here printing out like we're supposed to. And now the 2 is stored in the AX register. The 2 needs to go over here, oops, in the third one, which is A of 4 on our end. So then all this means is I'm going to go, okay, whatever's in the third element, 1, 4, gets a 2. And then the 3 is going to swap out. So we print this. You can see where this is going. We've got one more line of code after this once we get this going. Whoops. Uh-oh. Disabled. Never mind. Disable my virus checker. So now you can see 1, 4, 2, 1. And it's just one last thing to go and call it a day here. Exchange whatever's in AX with A of, and which one haven't I used yet? I haven't used A of 0. So then what will happen here is the AX register will hold the 1. And then I'll have my 3, 4, 2, 1, which is exactly what I want to see on the screen. So it only took 5 lines of code. And so I did all the things I'm supposed to do. I printed everything out. I swapped everything around as efficiently as possible. And then I printed everything out a second time. So what other things to note here? And again, I'm just using the short part of the register. I guess technically you could use the EAX register, but then I would have to do like a word pointer. It could get, or move. It just kind of gets a little complicated. This kind of keeps everything on in a simple way. I don't think I'm forgetting anything. I feel like I am, but I don't think I really am. And so that kind of describes the process here. So as always, thanks for sticking it out with me. Hope you guys learned something out of this. A fast and easy way to do this. If you have any questions or concerns, please comment below or email me at swardby@cod.edu. And I'll get back to you as soon as I can. Well, thanks for sticking it out with me as always, guys. Have a great day. See you in the next video. Take care.